Okay, so now let's start our process where we take this kind of curvy motion around the circle and turn it into kind of a rectilinear x and y coordinate. So here we are. We've moved what looks like 45 degrees partway through quadrant 1, exactly halfway through quadrant 1 for 45 degrees. And I'm interested in knowing what are my x and y coordinate here. Okay, now we have a beautiful relationship for these coordinates x and y, and it's exactly this. So this distance, this triangle right here, the distance across the bottom is the distance x. And the distance up the side is just my y coordinate. The x coordinate tells you how far over you are from 0, 0, and the y coordinate tells you how far up you are from 0, 0. So this coordinate x and y really is just telling us the sides of this triangle. And now we know that since we're in a unit circle, that our radius is 1. So now Pythagoras tells us that a squared plus b squared equals c squared. So we know that x squared plus y squared is equal to 1 squared, which is just 1. So this relationship holds no matter where we go in the unit circle. It'll work over here as well. So this point here has a different coordinate. We'll call it x1 and y1, just so you know it's not the same x and y as this. And we can see here that x1, in order to get to this point, we have to go to the left. So that means that x1 is going to be negative. So if we're talking about the side of a triangle, we can't really call it negative. So let's put a little absolute value on here just to be precise. So this distance here is the absolute value of x1, and straight up is going to be y1. But then when I take these sides of the triangle and do Pythagoras on them, I'm going to be saying a squared plus b squared equals c squared, which again is going to be the absolute value of x1 squared plus y1 squared equals, and the radius again is our hypotenuse, so that's 1 squared. But check this out, we've got the absolute value of x1 squared, but we know that no matter what we square, it becomes positive, so the absolute value is kind of overkill there, so we can just say x1 squared and know that we'll get the same answer as if we remove the minus sign first, because the square will remove the minus sign for us. So it looks like our coordinate over here, our x1, y1, also satisfies this relationship. So no matter where I go on the unit circle, the x coordinate squared plus the y coordinate squared equals 1. So here's an example. Let's just make a radical guess here. Let's say that this x coordinate, well, how can we figure out an estimate for this x coordinate? Let's go and figure out the 4 points that are easiest to label on the unit circle. So what is the x coordinate here? Well, the radius is pointing straight over to the right, and the radius is 1, so I've gone over 1, and I haven't gone up at all. And look, this x and this y satisfy our relationship, because 1 squared plus 0 squared equals 1. So even this point right here, which doesn't really make a triangle, still satisfies our relationship. When we head up here, radius is pointing straight up, so we haven't gone over at all, and we've gone up 1. Here the radius is pointing straight left, so we've gone 1 to the left, so minus 1, and we haven't gone up at all. And then down here, we just went straight down, so no motion right or left, and just straight down 1. Excellent, so those are the 4 easiest points to locate on the unit circle. Now, this might not be exactly right, but I just want to show you, well, let's say actually this looks like, let's just get rid of this because this x1 was referring to this triangle. So now that we're on this bottom triangle, it's kind of in our way. So let's just make that go away. And let's make an estimate for this y coordinate, just to make a point. So it looks like we're about halfway down to the bottom. So that means that this distance right here would be 0.5. Which means that I know, not my x coordinate, I don't know x here, but I do know that my y coordinate would be minus 0.5. So anytime you're in this situation on the unit circle, look, I know x, but I don't know y, but I know this relationship for x and y. So I can just sub one of the points in. So let's see, I don't know x, so I'll just put x squared, but I do know y. So here we're going to put 0.5, and then we're going to square it, and we're going to say that's equal to 1. So this means that x squared plus, now watch the negative disappear when I square it, so that's why we're saying it doesn't matter if we use the absolute value sign. 5 times 5 is 25, so this is 0.25, and that's equal to 1. So x squared is equal to 1 minus 0.25, which means that x squared is equal to 0.75, which we can write as a fraction. That's equal to 3/4. which means that x is equal to plus or minus the square root of that. So the square root of 3 is nothing easy to write down, so we'll just write the square root of 3, and the square root of 4 is actually 2. So I've gotten 2 answers out of Pythagoras' theorem. And which one should I choose? Well, I look at my point, and clearly I've moved to the right, so it must be the positive answer here. So x is equal to root 3 over 2. So we'll actually see this coordinate showing up because this is one of our special angles. But the main point that I wanted to make here is that if at any time you know your y-coordinate, you can figure out what your x-coordinate is, at least up to a sign. Then you might have to have some additional information like, hey, I'm in quadrant 4, and that tells me that my x-coordinate is positive. Okay, so that's the first step in going from this nice curvy motion into this rectilinear idea here.